Good morning, all of you. So we here started the group number 16 elements. That this group is called as oxygen family, which involve oxygen, sulfur, selenium, tellurium, and polonium. These elements are called as chalcogens, that is ore forming. What it means? That mostly these elements are present in earth crust with metals in combined state. That combined state is called as ore, hence collectively they are called as ore forming. Now some points about polonium. So it is radioactive element with half-life of 13.8 days. It is synthetic, that is, it is not natural but artificial element, and toxic in nature. As it is radioactive element, we will not study it with the rest of the elements. So if we discuss about their occurrence, then first one is oxygen. That is the most abundant element of all. It is the most abundant element of all, about 23% by mass of the atmosphere. Mostly produced by photosynthesis. As you all know about the photosynthesis process. Okay. Oxygen also present in the form of ozone layer, present in upper atmosphere, which protect us from ultraviolet radiations. Now if we discuss about its percentage in earth crust, then 46.6% by mass of earth's crust consists of oxygen. So these are the points related to oxygen. Mostly in combined state, it is present as oxide. Next one is sulfur. Its free state is diatomic, that is dioxygen. So in free state it is present as S8. It is 16th most abundant element in earth crust. In combined state, mostly it is present as sulfates and sulfides, such as gypsum, that is CaSO4 with 2H2O. For example, Glena, PBS, zinc blend, ZNS, and so on. These are the combined state of sulfur. Another major source to obtain the sulfur is also present as H2S, hydrogen sulfide, in natural gas and crude oil. So this one is the occurrence of sulfur. Other elements are less abundant. About selenium and tellurium, they obtained from anode mud in electrorefining. Anode mud in electrorefining, as this process is discussed already in electrochemistry chapter, that is unit 3rd, which is used to refine the metal by the help of electricity, that is called as electrorefining. And here the impurities are called as anode mud. Anode mud, that the compounds which deposit impurity, that deposit below the anode. Hence it is called as anode mud, which is consisting of those elements which are less electropositive. So selenium and tellurium, they are less electropositive. So now next is electronic configuration of these elements. So first one is oxygen, having 8 electrons, and when these electrons are distributed in the subshells, then its electronic configuration is 1s2, 2s2 and 2p4, or it can also written as helium, which cover the electronic configuration up to 1s2, continue with 2s2 and 2p4. Similarly, sulfur having atomic number 16, then the noble gas present previous to the sulfur, that is neon, which cover up 10 electrons, remaining are in 3rd shell, that is 3s2 and 3p4. Similarly, selenium with atomic number 34, it is written as argon, which cover up 18 electrons, and rest, as 3rd shell is started, then it also contains 3d, hence 3d10, 4s2 and 4p4. Now next one is tellurium with 52, noble gas is krypton, and 4d10, 5s2, 5p4. Okay, and last one is polonium with atomic number 84, xenon. Here, as 5th shell started, it also have 4f orbital, so completed it first, 4f14. Now next is 5d, and the valence shell is 6th, so 6s2 and 6p4. 4. This one is the electronic configuration for polonium, isn't it? The next one is atomic and physical properties of group number 16 elements. So they are the same as discussed in other groups, that is atomic ionic radii, metallic character, ionization enthalpy, electron gain enthalpy, and so on. Their variation is also the same as discussed in other groups. We here only focus on exceptions where they come. So started with first property, that is atomic and ionic radii. So about atomic and ionic radii, first of all we compare this property with the previous group, that is group number 15. So as we move from left to right, size decreases, hence atomic radii also decreases. It means group number 15 having large atomic as well as ionic radii in comparison to group number 16. Why it happened? Due to increase in nuclear charge. Its attraction, it means attraction of nucleus on electron increases, which decrease the size. Next one is down the group, atomic and ionic radii both increases as incoming electron enter into the new shell. Okay, so this one is the first atomic property. Next one is ionization enthalpy. Then similarly, first compare the first ionization enthalpy, or we can write it as IE1. That is the amount of energy needed to release first electron from an atom of element, that is called as ionization enthalpy. And if we compare this first ionization enthalpy of group number 15 and group number 16, so group number 15 having high value of ionization enthalpy than group number 16. Reason depend upon the electronic configuration, as group number 15 already have stable electronic configuration, that is half filled electronic configuration, hence it is not easy to release electron. But in case of group number 16, after losing one electron, they gain stable electronic configuration, hence they readily release one electron. Now next, about the same groups, that is second ionization enthalpy. So after releasing one electron from group number 15, its electronic configuration is NS2 and NP3. While releasing one electron, it becomes NS2 and NP2. Similarly, for group number 16, its electronic configuration is NS2 and NP4. But after releasing one electron, it becomes NS2 and NP3. See, it is the half-filled electronic configuration, and it is neither half-filled or fully filled, hence it is not much stable as compared to group number 16 after releasing one electron. So if we discuss about the second ionization enthalpy, then it is more in case of group number 16 than group number 15. Next one is down the group. So down the group, first and second ionization enthalpy decreases regularly as the size increases. As the size increases, it's easy to release one electron. Next property is electron gain enthalpy. So remember, with this property, if an atom easily gain an electron, then its electron gain enthalpy is large negative. And if an atom do not easily gain an electron, then it become less negative. So starting the comparison of group number 15 and group number 16, group number 15 atom size is larger in comparison to group number 16, and greater the size, not easy to gain the electron. Hence, in case of group number 16, it is large negative than group number 15. It means it is easy to gain the electron for group number 16 in comparison to group number 15, as they have only gained 2 electrons and they have gained 3 electrons to complete their electronic configuration. So next one is down the group. That is the important point here. Down the group, from oxygen to sulfur, it become more negative, and from sulfur to polonium, it become less negative. Why it so? Reason, as oxygen has smaller size, so what happened? Electron repulsion takes place, and it's 2p subshell. Hence, not easy to gain one more electron, which is not in case of sulfur, as the size of sulfur is large in comparison to oxygen. But next, as the size increases, what happen? It is difficult to gain the electron. Hence, if it does not gain electron easily, it become less and less negative. So this one is the electron gain enthalpy. Next one is the metallic property. So oxygen, sulfur, they are the known metals. Selenium, tellurium, they are the metalloids, and the polonium is the only element in group number 16 which is metal. So top to bottom metallic character increases and left to right metallic character decreases. Now next one is the melting point, boiling point and density. So in group number 16, from oxygen to tellurium, all these properties regularly increases as size increases, hence van der Waals interaction increases. Van der Waals interaction increases, but as we move from tellurium to polonium, what happened? All these property, that is melting point, that is boiling point and density, their value decreases. Why it so? Due to intervening of D and F electrons. Here the maximum number of electrons in inner D and F orbitals, hence it increase inert pair effect. What is the reason? That due to the intervening of D and F electrons, inert pair effect is maximum, or increase the inert pair effect, which results in S electrons do not available which decrease van der Waals interaction, hence decrease the melting point, boiling point and density. So polonium having less melting point, boiling point and density. Why it is so? Because it has maximum number of electrons in D and F orbitals which have poor shielding effect. It means that increase the inert pair effect as S electrons attract more toward the nucleus, hence not available in bonding, which decreases the van der Waals interaction. Next is the elemental state. So oxygen present as diatomic and other as octaatomic. Why oxygen present in diatomic? As oxygen having smaller size, have tendency to form p pi multiple bond, hence intermolecular force of attraction become weak in case of oxygen. So it is the elemental form of oxygen. And the last property is catenation. So sulfur having more catenation property in comparison to oxygen, as it has sulfur single bond and in its molecule it has a double bond. Hence, if another oxygen atom comes in contact with these atoms of oxygen, due to their smaller size and lone pair present on oxygen, they start to repel each other. Hence bonding is not strong. So here is the reason. Due to smaller size of oxygen and presence of lone pair of electrons, repulsion start. Okay, so these are the atomic and physical properties of group number 16 element.